Conversion of galvanometer to voltmeter. Now, we know that galvanometer, which is this circular symbol with an arrow inside, is a current indicating device or a moving coil used to indicate the flow of current. But however, we want to use it for the measurement of voltmeter or voltage. So we are converting it to a voltmeter. So how do we convert this to a voltmeter? We convert it by connecting a multiplier to the galvanometer. When we say a multiplier is a resistor connected in series with a device. So this resistor R here is connected in series to this galvanometer. Take note that this dotted line is not part of the circuit. We're just using it to indicate the voltage terminals of the resistor and the galvanometer and the total. So this is a series connection. This resistor is connected in series with the galvanometer, which can also be called a multiplier. The reason we call it a multiplier is that it multiplies the voltage. It increases the voltage drop across the entire network. So this galvanometer on its own has a limited voltage it can take for it to function. But since you want to convert it to a voltmeter in which it should be able to read a wider range of voltage, so in that case we connect a multiplier or a resistor so that this resistor will increase the voltage drop, thereby increasing the voltage range our voltmeter can read. And take note that this resistor or multiplier must be what? A high resistance must be a high resistance what? Resistor or high resistance multiplier. In the case of conversion to ammeter, we normally use a low resistance shunt. We normally use a low resistance. The reason in ammeter we use low resistance is that so that we can increase the range of currents it can measure. While here in voltmeter, we use a high resistance resistor. Reason being that with a high resistance brings about increase in voltage drop. From Ohm's law. V equals to IR. You see that V is directly proportional to R. Increase in resistance means what? Increase in voltage. Likewise, increase in current. Then for that of ammeter, you can see that current R equals to what? V over I. That means resistance is inversely proportional to current. So if you want to measure a wider current, or you can say I equals to what? V over R. For you to measure a wider current, your resistance should be small. So that is for ammeter, but we are in voltmeter, so you need a high resistance resistor for you to be able to measure a wide range of voltage. So let's go into further analysis here. So now V1 represents the voltage across the multiplier or the resistor in series. V2 represents the voltage across the galvanometer. Then V represents the voltage we want our voltmeter to read. That's voltmeter reading, or you say the total voltage. So V1, which is our voltage across multiplier, is given as what? The current through it. Remember, in a series connection, the same current flows through every device on that connection. So Ig, the current coming here, will be the same current in the resistor and also be the same current the galvanometer. So V1 will be what? I subscript G times what? R. And our V2 will be what? Still IG. So IG times what? Internal resistance of the galvanometer. Then our voltmeter reading, equivalent voltmeter reading, since it's a series, they are not the same. So you add, that will be V1 plus V2. V1 plus V2. So our voltmeter reading will now be what? I subscript G R, capital letter R, plus I subscript G, small letter r. You factor out galvanometer current. That's I subscript G. So you have I subscript G, open bracket, what will be left with what? Big R plus small r. So this is basically the relation that we normally use to analyze the galvanometer as a voltmeter. So since the determining factor of the range the voltmeter can measure is R, we make R the subject of the formula from here. So we start by taking Ig to the left hand side. So it will be V divided by what? I subscript G equals to R plus small r. Then we make big R the subject of the formula by taking small r to the other side. So we now have V over Ig minus internal resistance of the galvanometer. So this is the relation that we use for the design of a voltmeter. And of course, we have to calibrate our galvanometer, this thing, to be able to match the maximum voltage we want it to read. In higher level, in electrical engineering, we call this instrumentation, designing measuring instruments and how to control systems, instrumentation and control. Okay, so this is basically the relation you need for analysis of galvanometer as a voltmeter. Thank you.